Hey guys, Miss Fearing here. Today we're going to look at Unit 6 notes to some exponential functions. So we've talked about a couple different types of functions. We've talked about linear functions, and we know that those make a straight line. Those are our y equals mx plus b. We've talked about quadratic functions, and that's the shape of a parabola, and that's our y equals ax squared plus bx plus c. So now we're going to go ahead and we're going to look at what makes something an exponential function. So the standard form for exponential functions is y equals a times b to the x power, where a is greater than 0 and a cannot be 1. And the reason that this is an exponential function is because of the fact that the x is in the exponent. This is an exponent. So if we have that variable, that thing that's changing, as an exponent, then that ends up being an exponential function. So let's go ahead and look at example number 1 and look at graphing one of these exponential functions. That x is in the variable, so I know that it's going to be an exponential function, and all of our exponential functions are going to make a similar shape, just like our linear ones did and just like our quadratic functions did. So when we are graphing these, we want to go ahead and always use the same x values, and I always use -2, -1, 0, 1, 2, and 3. So those are the numbers that we're going to take, and we're going to plug that x in for the x in the equation to get our y values. So when you are plugging this into your calculator, you want to hit the y equals 4, and then there's a button that looks like a little up arrow. We call that the caret key. You want to hit that and then put in your -2 before hitting enter. If I go ahead and do that, I end up getting something that looks like 0.0625. So I'm going to do that for the -1 now, for caret key -1, and I'll get 0.25. Keep going for caret key 0. Remember, anything to the 0 power is a 1. Y equals 4 caret key 1. I get 4. Go ahead and put in a 2, and you should get 16. And then 4 to the 3rd power should give me 64. So I want to go ahead and I want to graph this the best that I possibly can. So at -2, I am just barely above 0. At -1, I am about a quarter of the way up. At 0, I am at 1. 1, I am up at 4. 2, I am up at 16. And then 3 is going to be all the way off my graph. So this shape that it makes ends up looking like a curve shape. And here's what you have to remember when you're graphing these. You never want to cross the x-axis. We can never ever get negative numbers when we're putting things into the powers. They get very, very small, but they never get negative. So we don't ever want to cross our x-axis down here. We don't ever want to cross this thing down here. The other thing that you have to be very careful of is I know that at 3, I'm going to be all the way up at 64. Be all the way up here somewhere. So we have to be very careful that I don't cross the 3 as well on this graph, because I won't cross 3 until it's all the way up at 64. So be careful when you're graphing these. I am going to be pretty particular about them. The last thing we're going to look at then is our y-intercept. Our y-intercept, where does it cross the y-axis? Where does it cross that y-axis? Well, it crosses at 1. You can go ahead and you can also look at your table, and we can see where does it cross. Well, we know x is going to be 0 at our y-axis, so you're really looking for that 0 number to find your y-intercept. So here's example number 2 now. I am again going to use the same numbers for my x value, so -2, -1, 0, 1, 2, 3. And I'm going to plug that -2 or that x value in for the x up here in this exponent. So we have to be careful when we plug this into our calculator. We want to hit 6 and then our parenthesis, 1 divided by 3, parenthesis, then our caret key, and -2. So if I went and I plugged all of that in, I ended up getting 54. So again, now we're going to plug a -1 in. So I'm going to do 6 parenthesis 1 divided by 3 parenthesis my caret key and -1. When I did that, I got 18. Now, when you plug a 0 in, careful, because anything to the 0 power is 1. So 1/3 to the 0 power is going to give me 1. But then I'm multiplying that by 6. So I end up getting 6. Keep going, and I get a 2. I get a 0.33 repeating, and then a 0.66 repeating. So I'm going to go ahead and I'm going to graph this up at -2. I'm going to be all the way up at 54 somewhere. At a -1, I'm going to be at 18. At 0, I'm going to be at 6. 1, I'll be up at 2. 2, I'm going to be at 0.33, so that's down here somewhere. And then 3, I'm at 0.66. So now this goes and makes the same shape, only it goes the other direction, which is okay. That's because this is a decreasing function. But we still have to be very, very careful that we don't cross that x-axis down here, and that we don't cross that -2 on this side. X is -2, because we want to be crossing the -2 up at the 54, which is off our graph. So again, be very careful when you're graphing these. Last thing we're going to go ahead and look for is our y-intercept. Where do I cross the y-axis? Well, I'm going to go ahead and look at my table and look for the 0 value. So I cross the y-axis at 6. So here's example number 3. We're going to do the same kind of idea. We just have to plug this all into our calculator a specific way. So we're going to go ahead and we're still going to look at our x values of -2, -1, 0, 1, 2, 3. We're going to take those x values and we're going to plug them in for the exponent up front. So I'm going to do 2 parentheses 0.5 parentheses caret key -2. I hit enter. So I hit enter. And then hit -1 and hit enter again. If you do that, I ended up getting 7. So try plugging that into your calculator. Really make sure that you're getting the same answers that I'm getting. I want you to pause the video right now, go through, finish the table, and graph it, and tell me my y-intercept, and then come back and check your answers before moving on to the next problem. So here's what I ended up getting when I plugged these in. If you got anything different, please come talk to me before moving on. Now, before I was saying we don't want to cross that x-axis, but what ended up happening was this -1 tells me I took that entire graph that we normally have that doesn't cross the x-axis and I shifted it down 1. So right now I should never cross the -1 down at that y equals -1. So just be careful. If you're really careful with your table and you graph your functions correctly, you should be fine. So here's example number 4. We're going to look at some applications now of how exponential functions are used. So number 4 tells me movie ticket sales decrease each weekend after an opening. The function here models our earnings of a popular movie. In that equation, E represents the earnings in millions of dollars, and W equals 0 represents the opening weekend. We want to graph the function and estimate how much money the movie will have made the opening weekend. So we're still going to do our -2, -1, 0, 1, 2, 3. And we're going to go ahead and we're going to plug those values in up here. So I'm going to have 49.9. And when we see that times, we can also write that as parentheses. So I'm going to do parentheses 0.692 caret key -2. When I do that, I get 104.2. So if I keep going through and plugging that into my calculator, I get 72.1, and then 49.9, and then I got 34.5, 23.9, and 16.5. So now we need to, at -2, be all the way up at 104. So we have to scale our axis pretty well here. To do that, I'm going to go up by tens. So I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then I'm still going to go over by 1. So I'm still going to have this be 1 and 2. So if I go ahead and I graph this at -2, I'd be all the way up at 104. So I'd be up here. At -1, I would be at 72. So I'd be somewhere down here. At 0, I'd be at 49.9, so almost to 50. At 1, I'd be at 34.5, almost 35. And then at 2, I'd be at 39, so 23, 10, 20, a little bit above 20. And then at 3, I'd be up at 16, so I'd be somewhere about right there. So my graph would end up looking something like this. Hopefully yours is a little nicer and goes through the points a little better than mine. But we can use this and we can look at how much money we made the opening weekend. Well, W is 0, represents our opening weekend. So we're looking at that 0 number again. So in my opening weekend, I made $49.9 million. Here's our next example here, number 5. Some people say that the value of a new car decreases as soon as it is driven off the lot. This function models the depreciation value of a new car that originally cost $25,000. V is going to represent the value of the car, and T is going to represent the time in years from the time of purchase. We want to graph the function and estimate the car's value after 5 years. So I want you to pause the video, and I want you to see if you can complete the table and the graph yourself, and then come back and we can go through finding the value after 5 years together. So here's what I ended up when I graphed mine. Your graph may look a little different. I labeled mine thousands, so I went up by 2,000s every single time. So again, just make sure your table looks the same. Your graph may look a little different depending on how you labeled yours. But we haven't actually answered the question yet. The question says, estimate the car's value after 5 years. So we know that T, this variable, is going to be 5. We're looking for after 5 years. So we can plug this in. V equals 25,000. And I always put B in parentheses, so times 0.28. And then we can hit our caret key, and we're going to plug in a 5. And when I did that, I ended up getting $9,268.50. So last thing we want to be able to do here is we want to be able to look at a chart and see if it is an exponential function. You could always go ahead and graph these and see if it made that shape that we were looking for. Remember, exponential shapes kind of look like this, or they kind of look like this, depending on if they're increasing or decreasing. But I want to go ahead and look at the table and see if I can figure it out without graphing. So to do that, I want to go ahead and I want to take 25 and divide it by 10. So we're going to do 25 divided by 10 in our calculator and get that growth rate or that exponential rate that we're going up by. And I would get 2.5. So that would be my multiplier. If I went ahead and I did that here and I did 62.5 divided by 25, so 62.5 divided by 25, I would end up getting another 2.5. I then want to try it for the last one here, 165.25 divided by 62.5. Ooh, that was green is a bad one there. Sorry, guys. But if you do that in your calculator, you end up getting 2.5. Because all of these are the same, 2.5, 2.5, 2.5, that proves to me that this is an exponential function. So you can write, yes, it is exponential. Let's look at this last one here, and we can go through and we can do the same thing. Remember, you want to do the 0.5 divided by 1. And when I did that, I ended up getting a 0.5. We can do 0.25 divided by 0.5. And I ended up getting a 0.5. And then we can do 0.125 divided by 0.25. And I'm getting a 0.5. These are all the same again, so this one is exponential as well. If you have any questions, please come talk to me before moving on to the practice.